If you have ever watched a YouTube video about quickly setting up your own Kubernetes cluster, trust me, they're wrong. And I destroyed one of my clusters to teach you how to set up your own Kubernetes cluster the right way. Now, in my previous episodes on how to build your own supercomputer, we set up the hardware. So we built our Turing Pi, we set up the nodes, we flashed them with an OS, and now we're ready to install our Kubernetes cluster. But before we're gonna do that, I'm gonna teach you guys about management organization and how to set it all up, including our cluster design. Now, here are some timestamps for those who cannot wait and want to jump ahead. Let's dive right in. I'm Garrett, and this is Timmertech. So in my intro, I made quite a bold statement. I said that if you ever watched one of those videos about quickly setting up a Kubernetes cluster, that is wrong. Now let me give you some more context and explain why. Everything is about time. To quote the historical Buddha, when he was asked, what is the biggest mistake we make in life? The Buddha replied, the biggest mistake is you think you have time. Time is free, but it is priceless. You cannot own it, but you can use it. You can't keep it, but you can spend it. And once it's lost, you can never get it back. That statement, that quote from the historical Buddha, is very important. It applies to everything in your life, and especially in IT, because it's easy to quickly set up things. But most people forget that by quickly setting up things, most of the time, people have not thought about maintenance and keeping things running. And that is why I believe quickly setting up a Kubernetes cluster is not the right way. And throughout this video, I hope that I can show you that taking your time setting it up will give you far more time in the long run, because that is what it's all about, time. Now let's get started on our first few topics. So we are going to cover 3 topics. We're going to talk requirements, then we're going to talk management, and then I'm going to draw out the cluster design. Well, first up, requirements. Let's talk requirements. And as you might have guessed from the introduction to this video, the most important thing here is time. And when we're talking about time, we want to reduce our maintenance and the overall time it will take us to build new things. The second thing we're going to talk about is storage. Well, when it comes to storage, what we want actually is we have workloads that we're going to run on our cluster, and they need to store data, like the data of a database or configuration or anything that the application requires. And in this particular scenario for this cluster, I'm going to go with Longhorn. Basically, it allows us to use our Turing Pi, which has each node has its own SSD drive, to use a portion of that and to make a volume on that, a little block of data. But the best part is we can replicate that to another node, and they will be kept in sync. So if the workload is being moved, or we're going to switch over, we're shutting down a node on maintenance, we still have a secondary or sometimes even a third copy of the data, and everything switches over and works seamlessly. Now, then also when it comes to storage, we need to talk about backups. Well, for backups, I'm gonna go with NFS. Now, in the case of a Turing Pi, there are multiple ways of doing it, but if you have an external data storage, like I have a Synology that I can use to store my backups. But in the case you don't have that, you can actually use the third node of your Turing Pi, connect a disk to the SATA ports, and actually run an NFS server on there. That way, we can have our Longhorn for storage, but have our backups of Longhorn and our snapshots of our data on a secondary drive out of the way. So that is what I recommend in our home setup that we can use for backups. Then what we're going to deal with is secret management. We need to store secrets. We have database servers, applications, user logins. There are certain scenarios where we need to store secrets. Well, we can always, of course, code them into configuration files or in secrets within the cluster. But I am actually going to go with HashiCorp Vault. A little bit more complex setup. Don't be scared. I'm going to run through everything with you once we get there. But it allows us to use secrets in a more manageable way. And how we're going to do that is we're going to put a layer between our Kubernetes cluster and HashiCorp Vault, and we're going to use ESO, External Secrets Operator. And that will form a layer between HashiCorp Vault and our cluster. The best part about that is that if we ever need to switch out our HashiCorp Vault, for example, for a cloud secret management tool or another, we can simply do that because ESO will provide the translation layer between those two, and we are able to switch out our secret management tool. Next is certificates. And I'm going to combine that with our next requirement, actually. And what I want is I want isolation of network traffic. And with that, what I mean is I want to isolate my external and internal traffic, meaning that websites or tools I want to expose to the internet, they will all go over the external traffic. And I want the internal tools, things that I do not want to expose, to run over internal. Now, basically what it means is we're going to set up two load balancers, one for external, one for internal traffic. And when it comes to certificates, this is linked. So the external traffic we want to secure with Let's Encrypt certificates. And our internal traffic we're going to secure with our own self-signed certificates. And that also allows us to create a certificate tree for other services in our network. For example, I have a Harbor running, which is a Docker repository on my Synology. And that's where I store production images. That way, if one of my clusters goes down, and instead of running a Docker registry in my cluster, which at that moment would not be available, I can fetch those images from my Docker registry on my Synology. And that Harbor Docker registry is secured with an internal certificate to have a nice TLS connection. So those two things are combined. Now, finally, what we want is we want to avoid circular dependencies. Basically meaning we want to avoid a chicken and an egg scenario. Who came first, right? Now, here's the thing. A lot of the times, without realizing, it's very easy to introduce a circular dependency, to introduce a situation where you have a chicken and an egg. The previous example I gave about the Docker registry is such a thing, right? A lot of people, they start building their cluster, they put a lot of tools and workloads in there, and some even say, hey, cool, I put my own Docker registry in my cluster. And they build images, they push them to the registry, and for some reason, at some point in time, there is a problem in the cluster, and the cluster goes down. Then you cannot start it up with the images from that Docker registry. So yeah, that's a perfect example of a chicken and egg situation, which we want to avoid. Next up is management. How are we going to manage everything? So for that, I'm going to use a bunch of tools. I'm going to use Ansible with an Ansible template of rolling out the cluster. I'm going to use a little bit Terraform. And I'm going to use helm and helmfile for the deployment of our workloads. Now, the reason for that is we want things to be reproducible as fast as possible. And that will save us time. Say that a node crashes or we have to replace one, it's beyond repair. Then we want to be able to quickly rebuild that node from source code instead of all kinds of manual actions where you don't have documentation, what goes first, etc. So we're going to put everything in infrastructure as code so that we can easily roll out or make changes. Also, what we're going to avoid is circular dependency. I talked about it before in our requirements. So here is what I'm going to do. I am going to put my workloads and at least the infrastructure workloads, that basically means the workloads that are responsible for infrastructure parts of the cluster, like load balancers and things like that. I'm going to put them in a Git repository. And I'm going to put them into a private Git repository on gitlab.com. Well, why gitlab.com and not GitHub? The reason is that GitLab actually comes with a really nice Kubernetes agent. So after I roll out the cluster, one of the first things I'm going to do is I'm going to install a GitLab agent into the cluster. And that will link it to a certain repository in gitlab.com. And then I can run a pipeline in gitlab.com and it will deploy a bunch of tools, basic setup, everything straight out of the box. And by keeping that separate, I can easily reproduce. Now, I also run my own GitLab. Why don't I put it in there? Well, the thing is, I'm going to run GitLab on this cluster. So the problem is that if I put this repository inside my own GitLab, I create a chicken and egg situation because, say, everything is down or I need to rebuild. Then I don't have GitLab yet running and I need to deploy the basic infrastructure like load balancers in the cluster. So as you can see, that creates a problem. So by putting that outside your own setup into a private GitLab repository, you can easily rebuild it using external tools. So that on management, always make sure that when you set something up, you ask yourself the question, what if everything is down and I need to rebuild? What do I need? Which steps do I need to follow to rebuild it as fast as possible? And do I create a dependency on something that's already running in the cluster? Because the moment you do that, it becomes a nightmare to rebuild. So, with that said, let's go into our cluster design. So we're finally ready for our cluster design. So what I'm going to do is I'm going to use my whiteboard and try to draw out everything that we talked about in our previous topics. So let me see if I can make this work. Whiteboard, activate drawing, and let's see if this works. Ta-da-da. Yes, perfect. Okay, so we have our Turing Pi, and our Turing Pi that I'm going to use for this cluster has 4 nodes, and we have 3 RK1s with 16 gigabytes of memory, and I have 1 NVIDIA Orin NX, and that one I am going to use for AI. So yeah, definitely watch future videos because I'm going to show you some real cool stuff. Now, this is our Turing Pi. I'm going to put a little bit like this, a box around it. to identify that this is our Turing Pi, right? Now, these are just our 4 nodes. And I'm going to draw a little line here. And the reason for that is that here on the left, this will be our Kubernetes cluster. And I'm going to use K3s for that, right? Our Kubernetes cluster. But these are the nodes. But here's what we're going to do. I'm going to also use HashiCorp Vault for our secret management. So I'm going to try, I'm still learning. This is pretty cool, actually. I'm getting better at this. Yeah, so we're going to draw 3 locks. And that will represent HashiCorp Vault for our secret management. And here we are going to have ESO. That's the external secret operator. And that's going to provide the translation layer between HashiCorp Vault and our cluster. So we only have to draw 1 because this is basically going into the cluster, right? Now, you might wonder, why am I not installing HashiCorp Vault as a workload in the Kubernetes cluster? Let me explain why. The thing is that there are workloads that are using secrets, right? Database credentials, etc. And the thing is, we want to be able, for easy management, to basically kill off a node for maintenance, reboot, etc. The thing is that when it comes back up, then the problem is, then it will have a problem. And what kind of problem do we have? Well, we have a problem that the HashiCorp Vault has to be available for the workload to start. Well, if you have only take 1 out, not a problem. But in a home lab, it is absolutely normal and common that you have to shut down a cluster. For example, right? I'm going to use my Synology NAS. So I'm going to draw that over here. I'm going to use my Synology NAS as an NFS server. Now, if you don't have that, then don't worry. You can still use Node 3 as a NFS server. But I'm going to use my Synology NAS with its disks for backup storage. The thing is that there's also data on there that I don't want on the nodes that will be accessed by NFS. The thing is, this is going to be my NAS. Sometimes you get updates for your Synology. And in order to do an update, it has to restart, which is kind of a problem if you have an entire cluster depending on that storage, right? So be able to shut down the entire cluster, right? With turning off all the nodes, allows me to do an update on my NAS, reboot it, wait a little bit, and then bring the cluster back online. And that's when we're hitting a snag. Because when HashiCorp Vault is running inside the cluster, that needs to be fully started before any other workload. Yes, there are ways you can work around that, and it's basically a nightmare. So what we want is, by putting a HashiCorp Vault instance on each node, it becomes redundant, right? If you can just restart one, there will be enough instances available. But the best part is that we can simply tell our OS, our Linux OS, that the K3s service is not allowed to start, and it has a dependency that on HashiCorp Vault, which means that I'm going to draw this a little bit better. So let's draw this. So this is going to be K3s, right? And like this. And we're going to tell the Linux service K3s that has a dependency on HashiCorp Vault. And that will ensure that the OS will first start HashiCorp Vault, right? And we can even put in there auto unseal in there, that being unsealed. And then when it's all ready, then Linux will start the K3S service, our Kubernetes cluster. And that way, when the cluster comes online, reinitialize itself, find the other nodes, the secret management is already available. So it can basically continue on starting all the workloads that were shut down before. So this is one way of avoiding the famous chicken and an egg problem, right? Just making sure that HashiCorp Vault with our secrets is started before we do K3S. And we still have ESO, which we're running in the cluster, but that should not really be a problem. We can actually probably give this a higher priority. We're going to figure this out together. Don't worry, we'll figure something out. Now, what else? Each node will have its own storage SSD drive, right? And as I said before, we're going to use Longhorn. I don't like this here. We're going to use Longhorn, which is a way of having volumes. That's basically little data blocks for each workload. And that way that we can duplicate it, which means that say that we have a workload running on this node, right? And it has its own hub. Let's see if I can draw this nice. We have data, right? Then there will be a identical clone, for example, on node number 3, right? And if we lose this node, if we lose node 1, we still have an identical clone. Kubernetes will reschedule that workload. And because we have a clone of the data, it will simply continue. It can actually decide, hey, I'm gonna start this workload of node number 2. I can actually move this data here. And then it will see, hey, I'm gonna wait a timeout for, like, example, 5 or 10, 15 minutes. If there's no response in, let's say, 15 minutes, then it will assume this entire data to be lost, and it will start recreating the data on other node, because we told it we want to have 2 replicas. We want the data to be identical across these nodes. So that is why we're going to use Longhorn for our storage. Let's paint this away. Let's erase this. Cool. Now, earlier I also talked about that we're going to have internal and external traffic, which is pretty cool. So here we have the internet, and here we have our router. Cool. Now, the thing is that we have, for example, I have 2 domains, and this is going to be our external traffic. This will serve the website and the tools that I want to be publicly available. But we also have our internal computer. I cannot draw. Ooh, well, looks a little bit like one. And we want this to go like this. So we want our external domains like .com, .io, .net. We want those to go over this external traffic. So this is going to be a external load balancer. And here we're going to have an internal load balancer that's going to serve our internal .k3s domain. And this allows us to have all our tools, administrator dashboards, things we definitely don't want to be available on the internet, to be available easily within our own internal network. We can just browse to the website of the tool, etc. And it's going to be served on a nice .k3s domain, and it will be completely isolated from our external traffic. So yeah, that's pretty cool. And to make sure, we're gonna have this, of course, this KVS domain, we're gonna have it served with TLS. So we're gonna have HTTPS, we're gonna have certificates for this. Now, what else? Oh, yeah. So one thing I talked about was where we're gonna store our infrastructure. So what we're also gonna have is we're gonna have a so-called, it's gonna be served on our .kvs. We're gonna have a master domain. And what this is gonna be a virtual IP. And this virtual IP is gonna give us cluster access. Ooh, that's not nice. Almost got it. So this virtual IP is gonna give us cluster access. Hey, why is it still? Ooh, help. Oh my God, let's try this again. So this is gonna be our cluster, access. Now here's the thing. We got 4 nodes, each one has their own IP. Now, and what we're gonna do is we're gonna use something called kubevip. And kubevip is gonna give a virtual IP. So let's say I'm gonna use .25 for node 1, because I'm gonna call it node 5. This is gonna be node 5, node 6, node 7, node 8. So I'm gonna use .25, .26, .27, and .28 for IP numbers. Now, if one node is offline, if in our config we're using that IP address to communicate to the cluster, to interact with it, to give commands, etc., then we cannot access it because it's not there. Now, and by creating a virtual cluster IP, I'm going to use .20 for that. So we always can communicate to our cluster and give commands regardless of which node is online, offline, in maintenance, etc. So we only have to set this once, and then any command we give with a tool like kubectl, like kubecontrol, is gonna be over this IP number. And this IP number, this .20, is gonna float around on the nodes. So let's say it is connected to the first one, to what's going to be in the future is going to be node 5. And we're going to take this offline. Well, then the .20 cluster IP is going to automatically be attached to one of the other nodes, and therefore still gives us always access to our cluster in a convenient way. So yeah, it's going to be pretty sweet setup. Then we need to talk about our management of our infrastructure. So for example, right now we talked secret management, and we talked about our load balancers here, right? Then we have a certificate manager, like cert manager, running in the cluster for our certificates. It's going to provide us with the Let's Encrypt certificates, and it's going to even issue certificates for the K3S domain. So we have a bunch of tools that needs to be deployed to the cluster. Now, so what we're going to do is, after we provision the cluster, we're going to install the GitLab agent. And what we're going to do is we're going to have a repository on gitlab.com. It's going to be a private repository. Ooh, that's not. Let's erase this. Let's try again. So, and this is going to be gitlab.com private repository, right? And it's going to communicate with our cluster through something called the GitLab agent, which means that our cluster will show up in gitlab.com. And that allows us that if we make changes in this repository, the workflow, the pipeline, can actually deploy straight into our cluster. And this way allows us to have management and control over infrastructure components like the load balancer, certificate management, all the basic core tools before we start running any kind of software or tool workload. So the basic stuff. It allows us to manage that in a nice environment in gitlab.com. And if everything is offline, if all the nodes are offline, this will still be there, which means that if we reset the cluster, we only have to reprovision it, set up the GitLab agent, and then very quickly, in a few minutes, we can everything with our configuration to be redeployed. So yeah, that covers it. That covers it for now. Now, if I have more things I'm going to change on the design, etc., I will inform about it in the next few videos. But this is it for now. So let's see if I can jump back to, let's see, turn this off. Then we're going to jump, and here we are again. Now, so I hope you enjoyed this. This is roughly what I'm going to build. I'm going to show you. Now, of course, why do I say roughly? This is the basic setup. And I'm saying that because design change over time. But now, at least we have a solid foundation on what we're going to work with, what our goals are, and how to make sure that we can reproduce it in the future in an easy, manageable way. This is the cluster design that we're going to be working with and that I'm going to build in the next few videos. I hope you enjoyed this video. Please comment below, smash that like button. It really helps me out. And with your comments, I can improve this. If you have any kind of questions or any new ideas, or you want to incorporate things, or things are unclear, please let me know. I would be happy to make additional videos about clarification, why I'm going to go with such a setup. So if you enjoyed this video, comment below, like and subscribe, and I'll see you guys in the next video. I am Garrett, and this is TheFatRat.